Hello, in this video, I'll look at the queue. I'll examine what it is, what it does, and at the end of the video, I'll go over the code. Throughout the video, I'll compare the queue to the stack. What is a queue? A queue is a linear structure, a bit like a stack in that respects. And it's also an ordered collection of items, which a stack would be the same thing. It has enqueue and dequeue methods. Where it really differs from a stack is in the first in, first out structure of it. There are some differences in enqueue as well, which you'll see in the coding part. Enqueue method uses insert, so that's different from a stack, which uses append because it appends something to the end of the list. We're going to use insert because we want to insert something at the beginning of the list. That has a complexity of on, whereas dequeue has a complexity of constant time because we're going to use pop just to pop things off at the end. Other queue methods are isEmpty and size. These methods will just tell us something. It will give us information about the queue itself. Just like a stack, a queue is a linear structure. And we call this end the rear. If you think of the index numbers, they'll be like that. This is going to be out, and this is in. So we use enqueue, and here we use dequeue. What goes on here is in this enqueue, we use insert. So we're going to insert something, and you would have your argument in there. So let's say we insert A. A would then go in there. So the A goes in there, but when we use insert again, insert B, A is going to be pushed into here, and B will go into there. And this keeps happening. So the more things you push into here, A moves to there, and then it moves to there, and then it moves to there, and all the way along. When you want to remove something, you use dequeue, and dequeue is just going to use pop. So whatever is the last item in the list, which would be at -1, will just be popped out. So that's really the big difference. There is the fact that this structure is using, let's use another color. first in, first out. Now that differs from a stack, where a stack uses last in, first out. It also, the queue is going to use insert, whereas a stack would use append, because a stack would append something to the end of a list, whereas a queue is going to insert something at the rear, what we call the rear. So it's going to insert at 0, which forces everything to move along. The insert will be set out like this. So here is the index, and this one is the item that you're going to be inserting. So this insert, that never changes. Only the item will change. Only this guy here. This is why we put it in a function, so we can guarantee that insert will always insert here, because you could do insert at position 2 and put a there, but then that's no good to us, is it really? So that's why we put it in a method. In that method we set out the rules for what we want it to do, and that's always going to be inserted in at 0. Other let's see what colors have we got here. Let's try this one. Other methods that we use is empty, which is just going to return true or false, and size, which is just going to give us the length of the list. Now let's look at the code. Again, we make a class for queue. We construct an empty list. We have the isEmpty, which is going to return true if it's empty and false if it's not empty. Now here's one of the differences from the stack, is this insert. So we're inserting at 0 and we're inserting some item. So we have to have some kind of input. It has an argument, basically. Here with dequeue, this is just the same as pop that we had in the stack, and size is just the size of the list. So this is basically this is queue, and again I've just added in this method here so that we can see what's going on. So if I create if I create a queue and then let's use this one, is empty. So you can see it returns true. Yes, it is empty. So if we populate it and then put something else in there. Now if we check it, we use this function down here just to check and see what's in it, so you can see what's going on. See, we put in 1 first. We put 1 in first, but 4 was the last one to be put in, and that's now at index 0, and 1 has been pushed all the way to index 3. So if I add something else into it, all of these are going to be pushed down, and this 1 will end up at index 4. So let's do that. And then do check. See, the last entry in is at 0, so it's at the rear or the back of the queue, and 1 is at the front, and it's been pushed there. They've shuffled along 1. So if we want to remove something from the queue, we use dequeue. What do you think it's going to show? What's going to happen? We get 1 because it's at the front of the queue. If we use dequeue again, we get 2. If we have a little look at check, we can see that the numbers are just being popped off, and 5, which was our last entry, is still at 0 and will be the last entry out. If we look at is empty again, let's move that out of the way. Now it says false because we have items in this list. And if we use size, it tells us that the size is 3. There's 3 things in there, 1, 2, 3. So that's how a queue works. It's pretty simple, pretty straightforward, but a useful structure, just the same as just the same as a stack is useful. So it's slightly different from a stack in respects that a stack will append things to the end and then pop things off of the end, whereas a queue inserts things to the back of the queue and pops things off at the end of the queue.
If you liked this video, give it a thumbs up and try out one of my other videos.